Now recording. So, hello and welcome everybody. Hope everybody's having a good day. Everybody looking forward to the weekend? Oh yeah. We're done with the SVG stuff now. We're moving on to our next topic, which is AJAX requests, AJAX communication. So it's kind of, we're going to talk more like big picture stuff to begin with for today. This won't be quite so code heavy a class today. I think over the course of the entire lesson we might be lucky if I put like 10 lines of code up. But that's okay because they are rather important lines of code. Okay? And we have to go through a lot of conceptual work to sort of get us to the point where we can get there. Alright? So what we are going to be talking about is AJAX. AJAX. And no, I am not talking about the famed champion of the Greeks during the Trojan War. That would be a fun class, but it is not this class. No, I am talking about asynchronous JavaScript and XML, AJAX. Does anybody already know what an AJAX request is? Nobody's heard of it before? Well, this is good. You will all be learning something today then. So, I would like to contextualize this for you in sort of the context of the ancient and contemporary internet, which is something I always find it's useful for people to kind of understand where we were and where we have traveled to over the course of the decades of the existence of the internet. So, let's start with fundamentals. The internet is made possible by HTTP communication. Can anybody tell me what HTTP stands for?
Hypertext Transfer Protocol?
That's correct. Hypertext Transfer Protocol. Very good. There are other packet formats as well. As you will find in server side, SQL, as well as being a language, is also a packet format. FTP is also a packet format. Can anybody tell me what FTP stands for? File Transfer Protocol. Very good. So you may be saying to yourself, seems like we transfer a lot of files via HTTP. Like that's most of the time the way that we transfer files, not using FTP. So clearly something has changed since those things were designed. So HTTP is Hypertext Transfer Protocol. So that begs the question, what is hypertext? Anybody have any guesses? Yes. So hypertext is text containing hyperlinks. Right? Now, the term hyperlink is not one that's in common usage anymore. It's a more archaic internet term. These days, we do not recognize a distinction that was recognized back in the 80s and 90s. Right? For us, links are just links. Right? But back then, there was a recognized difference between hyperlinks and just plain old-fashioned links. Anybody care to guess what the difference between a link and a hyperlink was? Any ideas?
Was the link just like internal?
Like it would take you to a new page, and the hyperlink would actually.
Precisely so. Very good. So a link was internal to a document. If you think on Wikipedia, right, the links to other positions in the articles on the sidebar, those are links but not hyperlinks. You don't have to reload the page, right? A hyperlink is a link to a document outside of the original document, right? So, in the original conception of the internet was basically designed as a great big distributed file system where everybody's files were linking to everybody else's files, right? That's the original conception of the internet as you would have seen it in the early to mid 90s, right? Now, the internet kind of started off as a bit of an academic plaything, you know. It was over time that this concept of, you know, an interconnected network of computers, an internet, if you were, this concept gradually gained popularity because it was a radical transformation of the way that information could be transferred, right? So over time, this HTTP format, which was only originally really designed for transferring hyperlinked text documents around, this had to deal with an increasingly large set of scenarios. It's like, oh, sure, it's very, very useful to have a document that links to other documents. What if I wanted an image in that document? Oh, well, HTTP now has to figure out how to transfer binary image data. And let me tell you, back in the 90s, you spent probably, 90% of your time loading a page, loading any image on that page. Like, it's difficult for people, all of you youngins, to appreciate this, but like, I remember in the delicate days of my youth, you would like, perhaps as a child, I was into Pokemon, right? The first one, right? And like, the game didn't tell you what all the Pokemon were, right? So, you go to this new thing called the internet, and you do an exciting thing, which is you download a page with pictures of every Pokemon on it. And this was an exciting thing for a child, and this would be most of your afternoon, because it would take that long to download all the images, right? Like, this is how it worked. You had 151 of the images on a page. They would load one at a time.
Good old dial-up.
That's right. And then it's like a game. It's like, okay, I'm going to scroll back up to the top and see if any loaded while I was looking at the bottom. Oh, I'm going to scroll to the bottom, let's see if any loaded while I was looking at the top. Right? This is what the internet used to be like for kids in the 90s, right? So please appreciate the gifts that you've been given by technology, right? Although that Minecraft principle of if you have to work harder for it, it's more valuable to you, kind of applies, But anyway, so the internet had to do more and more things. It's like, we want to load media files. Okay, now HTTP has to do media files. We want websites to be less ugly. Let's invent CSS. Okay, now we're dealing with CSS. Oh, wouldn't it be great if you could do like actual programming? It's like, well, that sounds like a terrible idea within the context of a browser. Downloading people's code from the internet. What could possibly go wrong? Invention of JavaScript, right? All of these things gradually led to the accumulation of additional functions and features into HTTP, until it sort of grows and bloats to the size that it was, let's say, around the year 2006, all right? It's about this time that serious programmers are starting to take notice of the internet. For a pretty considerable time, you weren't a real programmer if you did web programming. This was kind of like the culture of like the early thousands in the 90s. It's like, you know, your average programmer of proper programs, your average Java, C, C# programmer, kind of looked at web programming the same way that a hoity-toity landed nobility would look at the hired help and the scullery maid. You know, there was a kind of a classism thing going on between web programming and the rest of it, right? Like I remember personally when I was doing my bachelor's degree, which was I graduated in 2010, so I was in university around this period of time. Like I was doing robotics, which by no means was like proper programming either, right? But like even we roboticists looked down our noses. We looked down our prosthetic noses at the web programmers. It's like, you don't even need a university education to do that. Yeah. You're just writing HTML, and HTML isn't even a programming language. Oh, it sucks to be you. Of course, you know, history then told the tale. What am I doing for a living right now? Right? I'm teaching college students web programming. So, history has its turns. You know, the wheel of fortune ever turns, right? I very briefly had divine endorsement for what I was talking about. So gradually, like, the business interest became interested in the internet. You get the dot-com bubble, right? It's at this point that people start paying people serious money to develop web pages, right? And as serious people who make serious money are employed to develop web pages, programmers are like, you know, like we have a set of solutions to these problems from where we come from, you know? Like something like Java solves a lot of the problems that we have in web programming in particular ways, right? What we want, what we really need is some interfaces, some defined interfaces, similarly to how other, you know, proper programming languages work. So eventually, we work our way up to the idea that maybe, just maybe, the internet doesn't have to be a big distributed file system. Maybe we could treat the internet more like we're making function calls, rather than always thinking about things in the context of, I am taking a file from your server and I am bringing it into my server, right? This concept is the birth of the Web API, all right? So the term API it's unfortunately a very loosely defined one. It means different things in different contexts. When we use it in web programming, it means something quite specific. But for example, in Java, right, when you write a Java class, all of the methods and public instance variables in a class form the API for that class, the application programming interface, right? When I want to use a Java class, I want to use it by its public methods, right? In other sort of strongly object-oriented environments, you get similar ideas, right? In a lower level context like maybe C, right? The C programming language, you don't really think of API, the term API isn't really used. What you think of is a library. You import a library, and then you have library functions available to you. You call library functions to access functionality, and that is, fundamentally it's not very different from calling the method of a Java class, right? It's just the terminology was different back then. So really, a library in a kind of a lower level language sense, that also can be considered an application programming interface, API. Does that make sense? So far, you with me so far? Everybody with me so far? Okay. So, within web, right? HTTP itself is an interface, right? That's what it is. It is a protocol for one set of software to talk to another set of software. So HTTP itself, technically, you could consider it an API, right? But when we use the term API in a web programming context, we are usually not referring to all communication. We are using it to identify a subset of internet traffic where the goal of the traffic is not file transfer. The goal of the traffic is the more abstract idea of data transfer, right? So we send a packet to the server. The server does not necessarily respond to us with an HTML page or a CSS file or a JavaScript file or a PNG file or anything like that. We get string data. That string data does not need to originate in a file on the server. It could be generated by scripts and programs running on the server ad hoc as we go along, right? So in this way, we take HTTP communication and we make from it something quite similar to a function call. The way to think about API calls in a web context is to think, I am doing a function call over the internet, but fundamentally it's still a function call. I am naming what I want to call, I am giving it parameters, I am expecting a return result, right? There are a couple of caveats though. Unlike a function call to a function that is local to your machine, you have to deal with network latency, right? You can't you can't depend on hanging your program until it hears back from a server. That's just not practical. The server might be on the moon for all you know, right? So, although if it were on the moon, that would only be a 12-second latency. Mars is probably a better example. But even 12 seconds is a very long time in a program, right? So when we talk about APIs, most of what we are passing around is JSON, JavaScript object notation, right? We will get into JSON. Let's put a pin in that for the time being. We also, we pass around some XML, extensible markup language, and we can also pass around plain text. Although, because plain text is unstructured, it's usually not preferred outside of Hello World demo examples, right? That being said, that's where I'm going to start. You know, you want to start with the Hello World, right? So this approach to the internet, to some degree, liberated us from a number of constraints that were sort of native to the concept of the internet as file transfer, right? For one thing, it became possible for a page to load more data from a server without resetting itself. Like without reloading the page, right? If you think about the way that this problem was solved, like in the 90s and like late 90s, early noughties type territory, you can think of like old forum posts and stuff like that, right? When you looked at an old forum, it's like, okay, I've got, 20 entries on this page, and to get more entries, I have to click on the arrow at the bottom, and that takes me to the next page. I get the next 20 entries, and I have to flip through 3 pages to find out what's wrong with my Linux machine, right? These days, we have things like the social media doom scroll, right? So when you are consuming social media, you are thumbing through your feed, right? Your feed is hypothetically infinite, right? It would take you a very, very long time to reach the bottom of Twitter, for instance, right? And even if you did, what it would likely do is the recommendation algorithm would kick in and would start presenting you stuff you weren't subscribed to, so that you could literally scroll through Twitter infinitely. And if it ran out of that, it'd probably just show you stuff you'd already seen, and you wouldn't even remember that you'd seen it because you've scrolled through literally, millions upon millions upon millions of posts, right? So the question is, all my fine feathered friends, do you think you're downloading the entirety of Twitter's database to your phone every time? Not bloody likely, right? If there's one thing that I want to impress on every student who ever has me for a professor, it's the fundamental limitation of computers that they are not infinite, right? They do a good job of pretending to be infinite, but computers are finite machines, right? You cannot represent numbers with infinite precision, and you cannot hold an infinite amount of data. You can only hold very large amounts of data, right? And not on a phone. You need lots and lots and lots of servers. So what happens? This is how the social media doom scroll works, and this is actually also going to be your 5th assignment. When you load the page initially, you'll load maybe 30 posts, right? As you're scrolling through your 30 posts, there's a kind of a threshold somewhere near but not at the bottom. When you have made it to the threshold, the site makes an API call back to the server to load your next block of posts. You then travel into that next block of posts seamlessly without realizing that it even was the next block of posts, right? you can sometimes see the kind of outer edges of this algorithm if, like me, you're, I don't know, like slightly distrusting of back to top buttons. Sometimes they reload the feed, sometimes they don't. Can you ever tell? Who knows? But if you scroll back up to the top manually, you know it's the same feed that you were looking at before, right? So, or at least some of the time, it depends. But if you're doing the manual scroll back up to the top, you've already seen these posts, so you're probably going real fast, right? It's like, you know, you're kind of spinning the wheel to see how fast you can make it go, right? If you do that, like there's an upper threshold as well, right? Because it's deleting these things behind you as you go to save memory, right? So really at all times you're kind of looking at a window of the database that goes like that, right? So as you're scrolling up way too fast, it's not able to load the posts sufficiently quickly to keep up. So that's why when you're doing that, it'll stop, then you'll get your more posts, you'll scroll through those, it'll stop. It also depends on the speed of your internet connection, right? So all of that is made possible by the API call, rather than reloading the entire darned web page all at once. You can also look at this from a network efficiency standpoint. Do you need to load the whole web page each time, if all you need to do is update the data inside of the web page? No. And in fact, you can save a lot of server traffic by not reissuing pages that you don't need to reissue, right? Make sense? Like, I don't know if you've like kind of, you know, as an interesting intellectual exercise, if you ever like poked through the JavaScript on like a typical page you use, but like that's actually quite a long file a lot of the time, and there are usually multiple of them, right? So, you know, it's a non-trivial amount of data to load a page, right? Although it's probably trivial in comparison to even one image, but you know, so it goes. Savings are savings, no matter how small. So, does that make sense? Any questions about this? So I'd like to show you a graph now. This data is a little bit old, but it's a little bit old, but it's still very interesting, and it shows an interesting trend at a very important time. So it's actually a little bit difficult to find this data. Like I tried finding an updated version of this chart, and I couldn't. I could only find like people stating what the percentage was. But traffic composition by content type. So this is using Cloudflare. This is going to be biased towards API calls because generally, you know, Cloud is biased towards API calls because it's not like some Apache file server sitting in someone's basement, right? Not an insignificant player in the market, though. Also, you know, there's also the ancillary issue of basically Cloudflare scans every single packet that goes through it for this type of data, so if you want to use it, you know, just be aware of that, right? But the way that it's telling the difference between API calls and web calls is by the packet's stated content type. So API data is usually tagged application JSON, application XML, or text XML. That's how they're telling. Web, text HTML, application X JavaScript, application JavaScript, text CSS, and text JavaScript. Text plain is in its own category. So if you take all of their packets and bucket them by their content type, this is what you get. In February of 2021, API calls constituted over half of the traffic on Cloudflare. By December of that same year, you can see it's up a couple of percentage points. The most recent data I found, and I believe this is also for Cloudflare, by I think the first quarter of 2023, this had reached 72% of all internet traffic is API calls. We very much live in the age of API, right? So, like, writing an API call is it's a non-optional skill as a developer. Like, you need to understand how APIs work, right? Web APIs. So yeah, you can see that in both cases, the number of API calls is probably 3 times as much as like just general web traffic. If you discount media. Media is like, it's a little bit different because like it could be the result of an API call, or it could just be a file load. Like probably a similar percentage or a similar ratio here breaks down media requests, right? But we'll just call media and be done with it, right? So, and then this is like plain text. This is binary files other than media files. I'm not even sure what you would have as binary files other than media files. Maybe like, like executable downloads or stuff like that. But yeah, so API calls are extremely important. We now live in the age of the ChatGPT, and that thing runs on API calls, right? Like, we live in a day where you can write a program, you can write a daemon, which makes API calls to ChatGPT, harvests whatever output it produces, then makes some subsequent API calls to push that automatically to Twitter, also using API calls. This is what a Twitter chatbot is, structurally, and they're not hard to make. Basically, the thing that rate limits you is that people charge for API access over certain thresholds, right? So if you want to make, I think it's actually kind of ridiculous. Like on Twitter, I think they start charging you at like 10,000 API calls a day or something like that. So a thing that you have to understand about API calls, I would go out on a limb to say the majority of these are probably not user initiated, right? This is most likely, to a large extent, the internet talking to itself, right? These are bots talking to bots. These are bots talking to websites. Yeah, this is like a certain amount of this, a great deal of this is probably automatic traffic, if that makes sense. Any questions? Okay. So, having said all of that, let's work our way up to making an API call. Now, this topic forms a bridge between client side this semester and server side next semester, right? Now that we are talking about API calls, the server naturally gets integrated, right? We no longer have the luxury of developing our little JavaScript program, double-clicking on the HTML file to load it locally in the browser, and then seeing how our JavaScript runs, right? If you load a web page in local mode, there is no server for it to communicate with. So, any API calls will fail. You need a server to communicate with a server, right? So, we are going to, I'll show you two ways of working with the server. The first is to just use CS Unix directly, all right? Today that's what I'm going to do. I'm going to use CS Unix directly. There's another program that we have on Mohawk Apps called XAMPP. The purpose of XAMPP is to spoof a server. It sets up a little local server process running on your own local machine. It doesn't touch the internet, but because it simulates a server, you can send packets to it, you can get packets back from it, you can simulate a sort of real internet behavior using XAMPP, right? I'll show you how to use that next week. It takes a little bit to set up, right? So today I just want to focus on what is an API call. Okay? Sound good? Okay. So, in order to work directly with the server, we need to get Linuxy. Do I have any Linux people in the audience today? Yeah, there we go. Anybody else? No? Okay. So, here we go. First, let's load up PuTTY. We're going to be doing everything in the command line. All right? So, just so that everybody is aware, my personal position is that eventually every single one of you should become competent in Bash command line interfaces, right? Just to pull some additional data to support that point, if we take a look at the 2024 Stack Overflow Developer Survey, right? Technology, necessary, thank you. Right, so let's take a look at professional developers, all right? These are the most popular programming languages, according to Stack Overflow's professional developers. Number 1, JavaScript, SQL, HTML, CSS, Python, TypeScript, Bash. So Bash is considered more valuable by your average developer than Java. Okay? And you have a course on Java. Where's your course on Bash? That's what I want to know. I would love to write a course on Bash. Just do it just do Bash. Just nothing else, just Bash. Cut out all the frills, cut out all the nonsense, just Bash. I would love to do that. You're still going to have to learn it though. So, to connect to CS Unix, we will use a program that most of you have probably forgotten about. It's called PuTTY. Probably most of you set your password with this, last year, and remembered your password and haven't opened the thing since, right? Yeah. So PuTTY opens up a terminal session on the server. When I type commands into PuTTY, they are being executed on the server, right? It is a bash prompt with all of the general bash, well, it's got like the base command set. If you want anything else, I'll have to bug IT to have something installed. But here we go. I'm just going to improve the appearance. Here. Maybe we can get away from this. Okay, somebody sitting at the back of the room. Is this text legible?
Yes.
Good. csunix.mohawkcollege.ca port 22. Yes, fine. There we go. Log in as Moore. That's me. Because I'm I'm a professor, so I get my actual name. By the way, do you know what SA in your usernames actually stands for? Student account. Yeah. So, but kind of interestingly, although I'm a professor, I don't actually have like privileges. My account does not have privileges elevated above your accounts on the server. So if you think you're going to be very clever and hack into my CS Unix account, it won't do you any good. You still don't have root access to the server. Sorry, guys. IT administers it. Only IT has root access. So, even though I'm responsible for changing your passwords, I actually have to log in through like a web GUI to do it, if you can imagine. So, everybody look the other way while I enter my password. 1, 2. There we go. I usually make a joke that my password is 1, 2, 3, 4, 5. Yeah, just like in Spaceballs, which is a great movie if you haven't seen it, by the way. There we go. Behold, the bash prompt, not a bash prompt, the bash prompt, spoken with reverence. All right. So. Important terminology. Number 1, when you have a terminal session open, the cursor, the program, everything gets run inside of the current working directory. All right? So, the most basic thing that you have to know about bash is how to navigate the file system, right? So, when you load up your, and I hope at least a reasonable number of you have loaded up PuTTY and are logged in right now, right? I make motions towards you guys because you're sitting closest to the front, but that's also, my hand waves apply to everyone. So, when you open up a new session, you are dumped into your home folder, right? So on the hard drive of CS Unix, and by the way, it's not CS Unix really, it's CS Linux because it's Apache. Apache is Linux. That's okay. You have the root directory. Root directory is, wait, have I got my slashes backwards? I got my slashes backwards. Always with the slashes. There we go. So the root directory is /, right? Within the root directory, there is another directory called home. Home contains all of the student account directories, all of the professor account directories, and any other account directories that may exist, like the root account that IT probably uses to administer things, right? So, you know, your student account is in there, right? Also, my account, Moore. So your account is a folder, basically. No matter where you are in the file system, you can always see the location of the working directory using the following command. Write these commands down somewhere, please.
Sorry, Professor.
Eh? What? Sorry.
I haven't accessed the console. Can you show me how to do it?
Is anybody else having troubles logging in? Okay. If there's only two of you, then. So, csunix.mohawkcollege.ca.
Yes.
Mohawk College. .ca. That was CAS. Yes. Oh, if there's one thing programming punishes you for, it's inaccurate constructs. Well, while you're doing that, you need PuTTY. csunix.mohawkcollege.ca, where the cursor is. Okay.
Now, it's currently
Now enter your account number. The login information is the same as for Windows. Just about yes. And now enter your WinSCP credentials. Okay. So, the command which shows you where you are in your file system is pwd print working directory. Okay, so that's your first command, print working directory. Next, in order to navigate your file, your folder structure, your directory structure, you need to be able to see what is in a folder. The command for that is ls. ls. When I type ls, you can see that I have several files in my home directory, including public_HTML. Now, Apache servers are configured so that the contents of public HTML are mapped to the Apache file server, right? If I request a file from this user account, this is where it looks for it, right? So, I want to do stuff inside of public HTML. I want to change my current working directory to public HTML. The command for doing so, cd, change directory, public HTML. There we go. If I print my working directory again, you can see that I'm now in home/more/public HTML. Make sense? So far, so good? Everybody following along? You don't count though, you already know this. So, ls to see where we are. I see that I already have, oh, and by the way, this is in my public folder, so if you see any files in here, you can just directly access them on my CSU account if you're interested in seeing anything. Winter 2025, unfortunately the color coding isn't coming through on PuTTY, right? But normally folders are blue, executables are green. So that would be blue normally, but W 2025, that is the folder that I want to put this work in. CD W 2025. There we go. So I would like to make a new directory for the work that we are all doing today. All right. The command to create a new directory, mkdir, make directory. I'll just supply today's date, 21, there we go. Now, viewing the contents of the folder, you can see this new directory has been created. We can change directory, cd 2025-03-21. There we have it. Nothing is currently in this folder. We just created it. So, let me show you something else that's cool. This is the current path to my working directory. If you take the portion of this path which occurs after public HTML, that's the part that you take and apply to the URL to access the folder from a web browser. Let me demonstrate. CS Unix, there we go. More 2025. So, after the account name has been provided, you can see that path there matches the working directory that I'm in on the server. Make sense? And you can see I get Apache's default there's no index page in this folder view. Anytime you try to load a directory from an Apache server that does not have an index page, that's what you are presented with. That's the default behavior. Does that make sense? So far so good. So now, we have no index page. Let's make an index page. What editor am I about to use? Say,
I'm still new to it. So I'm still new to Linux. I don't know what else.
Well, in that case, what editor would you use?
Just in general, make an index, or
Sorry, what?
like just to make an index in general, or
Yeah.
I don't know, like just I can use the default one.
Okay. But you would probably use the GUI version, right? You don't do much of this like in terminal?
I use the terminal a lot, but never like that. I've never used it to do other stuff like that.
Let me give you a grand gift.
Okay.
The program Nano. Nano index.html. So Nano, you can think of this like in-terminal Notepad, but a little better than Notepad because it does syntax highlighting. Right? So, but fundamentally, like no autocomplete, this is Notepad equivalent, right? We got HTML, we got the body, and the body, H1, Ajax, and H1. We will also need some JavaScript. Should put that in the head. Maybe I'll throw doc type in there too, why not? HTML. I'll give you guys a moment. All right. How many people have got that down? How many people are still working on it? Well, hurry up. Okay. So, Nano is one of the more user-friendly of these types of applications because along the bottom it gives you what the commands are, whereas most like Linux programs are kind of designed where like look it up in the manual. The design philosophy of Linux is if you don't know something, look it up. If you don't know something, consult the manual. So this is kind of nice. It's nice, easy intro for beginners because it gives you some of them anyway. G is get help. S is save. But this little tick means control, so it's Control S for save. Control S, Control X to exit. You'll find that, like generally, most of the shortcuts in Nano kind of make sense based on like what you're used to. Sort of, except like search is W for where is, but whatever. That's like because it can't be S, or F might be found something else. Anyway, I don't know. We need JavaScript. Ajax.js. Let's do some Ajax. Yay. Just a little console log to inform us that the JavaScript has been loaded. If we go back to the browser, reload, there you go. Ajax, check the JavaScript console, inspect, console, there we go. Now, So you remember all of that fancy talk where I was talking about, oh, Ajax doesn't have to access a file, it can access lots of different things. Well, the first thing we're going to use is to use Ajax to access a file. So, in order to access a file, we need a file to access. So, let's create a new plain text file. Oh, yes, I do want to save the buffer, thank you very much. If it asks you if you want to save the buffer is your file. So yes, you do want to save it. Unless you don't. Now, hello.txt. Yar. Var be JavaScript. Afoot, me hearties. There we go. Or some other similar greeting message. Save, exit. I'm going to sneeze. Possibly. Whenever I say that, there's like a 50% chance I won't. Let me give you another bash command which is extremely useful. Cat. If you wish to view the contents of a file without opening it for editing, the cat command will basically print the contents of whatever file you give it. Make sense? So far so good? Is everybody following along? Cool. So, yeah. Stay. So now, it is our objective to load this text into the JavaScript console using an API call, using an Ajax request. In JavaScript, Ajax calls, Ajax requests, are very often called fetch requests for the following reason. The way you do them is by using the fetch function. Fetch, and then you specify the URL relative to the current one that you want to access. Fetch hello.txt. Now, just for interest, let's drop the return result of that fetch request into the console so that we can maybe pick it apart a little bit, take a look at what it is, actually dissect it. Sound good? So, it has done something. We have a promise. Let's take a look at what this promise contains. We have a promise, we have a promise state fulfilled, and we have a response. The response contains all kinds of information, including a lot of information that is contained in the header of the data packet. Pardon me, I just have to do my sheet. This is a slightly inconvenient way to view this data. Modern browsers provide us an easier way of viewing packets. But that's essentially what this is. This is, I have taken all of the JavaScript apparatus that surrounds a packet, and I've dumped that into the console. Does that make sense? The browser tracks this information without you having to go to the console for it. So, has anybody shown you the network tab yet? Well, prepare to be amazed. Now that we're actually communicating with the server, the network tab becomes highly interesting. If you have the inspector pane open while you're making requests, while you load the page, it keeps a record of each communication with the server. So far, to load this page, we have communicated with the server 3 times. The initial communication was to load the directory itself, which of course redirects to the index page in Apache. Much information is available inside of the header. Things like the URL that we were trying to access, the remote address including IP address and port information, what was the status code returned from the server, what was the method of the request, all of this information, and much more information besides. What is my operating system? What is my browser? What is my browser version? What is the content type that was sent? When things like Google Ads produce reports, what they are doing is harvesting this data specifically and tabulating it. That's all they're doing. You can tell quite a lot about internet traffic just from this, right? This is the unencrypted header. All of this information is public anytime you make an HTTP request, right? So any server that the packet travels through can also collate this type of information. For example, it would be extremely reasonable for an internet service provider to read packets and determine what is the percent usage of Windows versus Mac versus Linux of all of the people on my network. All they would have to do is, for a sampling period, maybe a week, measure, tabulate what's coming through on CHUA platform. Tabulate that data, you can get there. This is the same way that the graph we were looking at earlier was produced, by looking at the content type in the header. Does that make sense? So far, so good? So, within the network tab, probably the tab that you folks will be most interested in is the response tab. You can see this is the content of the index page that we wrote on the server. It has been sent as the response. Very good. When the browser receives the response, it takes that code and plugs it into the HTML parsing engine, the HTML interpreter, which, as we know, interprets the file one line at a time. So, we process this line, that line, that line, that line. Uh-oh! Do we have this file? Not yet. When the parser hits the script tag, it says, oh, I need another file from the server. So, it initiates a new request. It starts a new packet sends that packet back to the server. And you can see that the server sends back the contents of our JavaScript. Make sense? And as we know, the browser executes this code immediately upon receipt of it. So, it then immediately proceeds to execute this console log and then the fetch statement on line 3. The fetch statement on line 3 says, hey, go back to the server and get me this information, hello.txt. So, a new packet is begun for hello.txt. We can see that the response text of this packet is the contents of hello.txt. Okay, good. So the response did come through. What remains to us now is to take the result of the the result of the fetch request and break the data out of the containing structures. There is a specific way that you do that, right? But first, we have to talk about what a callback function is, right? So, when we undergo server communication, as has been previously stated, that communication takes time, right? We can initiate communication today and hear back tomorrow. It is possible. Although, reasonably, the network would probably drop the communication before that occurred. So, our browser doesn't wait for the packet to be received back before continuing. Not in the case of an AJAX request. It does do that when it's loading JavaScript. Effectively, because we're parsing our HTML one line at a time, that parser is paused while it's fetching the JavaScript so that it can run the JavaScript and then continue HTML parsing, regardless how long it takes to fetch that JavaScript. Make sense? Now, it's a little bit different. Well, sometimes with CSS, the CSS doesn't load immediately. You notice this? Like, if you get like a really like blank white page with a bunch of text going down like that, what's happened is the CSS has failed to load for whatever reason. Maybe it didn't make it through the network. It doesn't happen often, but it happens occasionally, right? Most people will reload the page, right? Occasionally, if you just sit and look at it, the CSS will come through. So that's being done asynchronously. But not JavaScript. Not JavaScript. Okay? So, the way that this communication works, we make a promise. We say, when I hear back from the server, I am going to run this function. That's the promise. The callback function is the function which is run when we hear back. Does that make sense? So basically, what we need here is a callback function which helps us break the data we want out of the data structures that JavaScript wraps the thing in, which are important but not important to us, right? So, in JavaScript, when we write a callback function for a fetch request, and by the way, I am deleting the console log that was wrapping the fetch request. We use the method then. Now, I just want to touch on a syntactic thing for a moment. You haven't really run into this too much in this course so far. A little bit with event handlers, and you'll notice that to get a DOM reference takes a lot of dots, right? This is called method chaining, right? This is basically the way that JavaScript likes to think about itself, right? JavaScript programmers are very comfortable chaining multiple methods together, right? At the moment, we're only calling one method, but we will be chaining methods here as well. A syntactic thing which is sometimes done to make it more readable, if the method contains, if the method is long, you put it on the next line, indented slightly, and that gives it, it makes it look like a new statement. It's actually not a new statement. The statement ends where the semicolon is, right? But, it's kind of just the way JavaScript is designed. You can have a whole program that does a whole lot with 3 statements, but those statements are each statement is 50 or 60 lines long, that's just kind of the way that JavaScript works. That's the way it looks and feels. Is it ideal? No. But this is JavaScript after all. So basically, understand that this is a method call, but it kind of looks and feels like a statement. Okay? This thing expects a function as its input, to be applied to the data passed into it. So, I'm going to use an arrow function here. There we go. Console.log data. Save, reload, let's take a look at our console. So now, you can see that we've broken this thing out of its top layer. We've now isolated the response. But as you can see, we still have reasonable ways to go before we have our actual honest-to-goodness content out of this thing. It's, it's contained somewhere in here somewhere. Fortunately, we are provided with a method which we can apply inside of here to assist us in breaking this thing out again. In our case, we're going to use the text method, data.text. When we do so, you can see that data.text has returned us back to the level of a promise, but promise result has, it's no longer a response packet, it is the text content of that response. But we're back in a situation where we have the promise object. We need to break our data out of the promise. So what we do is we apply another then method to this. That will break the data out, get us this thing. Okay? I'm going through all of the various stages in this, hopefully so that you guys understand a little bit what's going on, as opposed to the approach of just like memorizing the lines of code, right? So we need to break the data, which is now text data, out of the promise. Text. Be sure to remove the console log statement there. So now you can kind of see how these then methods are kind of looking like statements, right? Make sense? Everybody got that down? So now, if we go back to the browser, you can see the thing which we are logging is now the string we were looking for. We have obtained the data. And of course, if we want to do something a little bit JavaScripty with that, we could do something like this. Function document. Oh, wait. Function text document dot query selector. I don't actually have anything to select. I'm going to make something that says output dot inner HTML is equal to text. There we go. Technically, with a lambda function, you can open up a new code block by using curly braces, but whenever I want like block code rather than just one line, I tend to use an anonymous function rather than a lambda. It's just me. You guys can do what you like. Both ways work. Make sense? So, if I save that, let's open up our index page again. There we go. ID is equal to output. Output, there we go. Reloading the page. You can see our data has been successfully integrated into the web page. Huzzah. Any questions? Well, if there are no questions, I think it's about time we had our break. It's about the middle of class. So, it's currently 11:24. I'll give you 16 minutes today. Let's be back here by 11:40, shall we?
No.
So, you may remember me saying from the first half of this that when we are doing API calls, the majority of the data which we are pulling up is going to be JSON data. So we should do we should have an exploration of JSON data. What is it? What does it look like? How do you work with it? What is it syntactically? What is it semantically? So, yeah. I've already mentioned that JSON stands for JavaScript Object Notation. Although it originated in JavaScript, you will find that JSON or JSON-like formats are quite popular. Many programs use them, not just JavaScript. But it's still generally referred to as JSON. So, let's talk about the way that we store data, right? Does anybody recall? Here's a little recall exercise for you. I showed you folks the Stack Overflow developer survey of most popular programming languages last year. Does anybody remember what language number 2 was?
SQL.
SQL, that's right. Does anybody know what SQL stands for?
Structured query language.
That's correct. Structured query language. So, when you folks make it to 3rd semester, which hopefully will be in the fall, I'm sure that's if you're in class, you're probably going to pass the course. That's just kind of how it goes, you know. When you hit 3rd semester, there is a course in there called Database Theory. I believe it's called Database Theory. You'll be taking it concurrently with server side, right? That course teaches SQL, right? Now, SQL, like the best mental model for it is it's very similar to an Excel spreadsheet in terms of its structure. You have tables, which are like sheets. You have columns, you have rows. Wait. Columns, rows. That's how it goes. I sometimes refer to this as rectangular data, right? Because the data is occurring, broadly speaking, in rectangles, right? SQL has been around for a very long time. Initial versions of it, I think, date back to the 70s. When you program in SQL, it feels like an old language, right? That said, SQL is an exemplary example of a language that does one thing and does it exceptionally well, right? You can think of it this way. SQL databases have had 50 years plus of optimization, algorithmic optimization, put into them. They are extremely good at what they do. That being said, the format of the data in an SQL database could be considered a little restrictive. Maybe we don't want our data stored in rectangles. Maybe, how about that? Maybe we want to do something a little more flexible. Did you consider that SQL? And SQL is like, I am SQL. I am just SQL. You don't understand. I am just SQL. That is all I do. So, a trend which I think started about 15 years ago, 10, 15 years ago, was these, can we do a database? Can we do a database, guys? With no SQL at all. The, if you will, non-SQL database. Scandalous. So, yes, it turns out you can do a database without doing SQL, much as the haters said back in a decade and a half ago. One database system which, like basically the most popular non-SQL database out there is a system called Mongo, MongoDB. How many people have heard of Mongo? A couple of people. So, heard of Mongo, have you used it? Not really?
A little bit.
Little bit? So, whereas an SQL database stores its data in tables, Mongo stores its data in JSON. Right? The underlying data format for many non-SQL databases is JSON. That's how powerful JSON is. Right? Now, I don't think that we're in a situation with databases similarly to how we were between like API calls and regular web packets, right? I do not believe personally, and you know, this is my personal opinion, you can take it or leave it, but this is my opinion, and you know, I do have a PhD, so you know. My opinion, SQL has been around so long and is so well integrated and so well optimized, so good at what it does, it will never go away. SQL is here permanently. Mongo will, and other non-SQL databases, will eat away a certain amount of market share, right? But there's a large category of fundamental applications that SQL will never not be used for. Good example, login systems. Anytime you've ever had a login system, I would put good money on SQL being the back end. And hackers also put good money on that. Anytime you're looking at financial transaction records, that is most likely an SQL database that you're looking at, right? Like the Google Play games that you've downloaded that are associated with your account on your phone, if you have an Android phone. I would put money on that being an SQL database in the back end. SQL is very, 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 very fast. Very well optimized. But again, not so flexible. So what are the sorts of things that Mongo is used for? What do we use JSON for? A lot of social media posts, if you kind of dig into what is actually transferred to you, the social media consumer, that's most of the time JSON. A lot of the time in the database it's JSON as well. Basically, JSON works well when fields can be missing and you don't want to take up space recording missing fields. That's one way that JSON-based databases are effective. And honestly, in server side, when we write code that communicates with an SQL database and sends that data back to the client, it's going to be JSON encoded anyway, right? Like the PHP server will convert from, the table of records format that the SQL database gives you, and it will convert it to JSON so it can be sent back to the client. Does that make sense? So, let's go over the basics. What is JSON even for? Why? Why JSON? What is JSON? So, JSON solves a problem, right? Here's the problem that it solves. Let's say that we have a client represented by a monitor, which very few clients actually have anymore. Let's say that in the JavaScript on this client, we have a data structure that we want to send to the server. We just want to pick a data structure up, push it out to the server, right? It's like, you know, let's imagine it's a JavaScript object, right? Fruits. Let fruits equal apple, 5, banana, 10. Someone give me a fruit.
Orange.
Orange, very classic choice. 15. Right? JavaScript object. In order to use JavaScript object notation, you need to know what a JavaScript object is, right? It is a collection of key-value pairs. These are the keys, these are the values. You can get to the values through the keys. If I say fruit dot apple, that yields 5. Make sense? So far, so good. So this is a data structure, right? This is a data structure. We can address it. We can do stuff with it. What we cannot do is send it over an HTTP connection. It's not in a format that permits transmission, right? Like, you have to understand, variables don't really exist. Variable names don't really exist. They only exist for us, right? Once that code gets compiled and interpreted, these bad boys are replaced with memory addresses and memory offsets. These become numbers. Only we see them as words, right? That is not suitable to be sent to the server because what the heck does the server care what the memory offset was for some data structure on the client? What? I don't need to know about your data, your memory management, man. I just want the data. So, in order to send something like that over here, we must pass it through HTTP communication. HTTP communication has 2 data formats. Would anybody care to guess what they are? Everything else is window dressing. Yes?
Plain text.
Plain text and
Can't remember the last one.
I'm not going to say yes, because you need to, basically you need to say both so like I can see the dichotomy, right? To see if you understand what you're talking about. So, what are the 2 data formats in HTTP? You want a hint? The hint is, it's the same 2 data formats in files. All files are either this or that. All files are either blank encoded or blank encoded. Come on, this is a smart class. I know you can do it.
Is it binary?
Binary is one. What's the other? All files are binary encoded or
Is it UTF-8 or something?
you're too specific, but yes. Binary encoded or character encoded, right? UTF is a character encoding, but it doesn't have to be UTF, right? It doesn't have to be UTF-8. It could be UTF-16. It could be plain old 7-bit ASCII if you want, right? The particular character encoding doesn't really matter. What matters is that it is character encoded, right? Character encoded is a fancy term for string data, right? So, HTTP transfers either binary encoded information or character encoded information. The binary encoded information is typically media files, executables, stuff of that nature. As it exists in JavaScript, this is binary encoded. It's binary encoded at the level of the programming language itself, because if it were character encoded, that would be ridiculous, right? It would take way too long to, okay, now I gotta encode it, now I gotta decode it, now I gotta encode it again, now I gotta decode it again. Like everything you tried to do with anything would take at least 10 times as long as it would otherwise if you weren't working in pure native binary data, right? So, JSON is a character encoding of this binary data, right? JSON is strings. JSON is equal to string. In fact, I'm not even going to say equal to, I'm going to say JSON is defined as string. Whenever you're working with JSON, it is string. Okay? Strings can easily be transported by HTTP. This is what we've been doing this entire time. We haven't, every single packet we've done so far has been a string. We haven't even done binary communication yet, right? So we must take the data structure natively encoded in JavaScript, convert it to a string, send it over HTTP. JavaScript provides a function to do this, but the name is stupid. The function is, from the JSON library, JSON.stringify. I'm disappointed in you, JavaScript. For the umpteen gazillionth time this semester, I'm disappointed in you. There is a proper term for that, by the way. It's called encoding. But so JSON.stringify produces a string version of this. Now, the conversion itself is not as, it's quite easy for us to understand, to the point where you can often confuse, as a human, you can confuse this before and after conversion process, right? Because basically, from our perspective as users, all it's doing is slapping two quotation marks on either end. Oh, it's a string now, right? Now there's a lot more that goes on behind the scenes, right? Relating to binary data, etc. But JSON format is how you would enter the data structure in JavaScript itself. If you take that string, which, is in the JavaScript code itself, put quotes around it, it's a JSON string. Does that make sense? Any questions? So far, so good? So, now, we take this, we send it to the server receives it, the server is like, I can see from the content type that this is JSON data. Yes, very good, very good. But it's still a string, so the server, in order to perform operations like this, the server must decode the JSON and turn it back into a data structure. A data structure in the native constructs of the language. Because we will, unfortunately, be studying PHP, I will show you the methods that PHP uses to do this. PHP there you go. Little pukey face. So, when the data is received, we pass it into JSON underscore decode. We then get our data structure out of that. A thing that you actually can do quite like an operation that's pretty not infrequent is you kick a data structure out to the server. The server modifies it slightly, mutates it in some way, and then kicks it back. Right? Like the data that you send and the data that you receive back could be largely the same data structure. Now you could make the argument well, if you trimmed that down, you'd save some network traffic. And that's true, but at our level, we're not necessarily worried about those types of considerations just yet, right? That's the kind of thing that when your boss says to you, "Oh, look at all these server costs. Our server transfer data is astronomical. You, Jenkins, make that problem go away." It's okay, sir, well, I guess we could trim out some of the redundant data that we're sending around. It's yes, Jenkins, that sounds like an excellent plan. You have 3 minutes to do so. We're losing money now! But, anyway, when you want to send the data back, you pass it through JSON underscore encode. This turns it back into a string, which can be sent back in a response packet, sent back into the JavaScript, at which point we call a related function, json.parse, which, by the way, is the correct term. It's a correct term for what's going on. Stringify, I hate it. I hate that word so much. That turns it back into one of these. Does that make sense? So, when you are sending complicated data structures between client and server, here's the takeaway, right? When you are sending native data structures between client and server, you cannot do so as a native data structure. You must convert to and from string on either end. JSON stringify, JSON parse, JSON decode, JSON encode. These are the functions on the server and the client which allow large data structures to be sent back and forth. Make sense? So far, so good? Okay. Does anybody want a picture of that before I erase it? Okay. So, tea bag flopped and splashed tea into my mustache. All right, everybody cool? All right, next slide. So, now, I'd like to give you a kind of a feel, like an impression, for how JSON data is worked with practically. Now, in order to do, basically I'm going to put it like a, still fairly simple, but a JSON with a couple of layers on it, and I'll show you how to like get data out of it, put data into it. Okay, so let's imagine that we wanted to encode information about a family. Nobody's in particular. There we go. So, at the top level of a JSON, most of the time you will find an object. This is because most of the time, even if you have like a list of things, you'll want to refer to that list of things by a name to distinguish it from all of the other data that you can keep about something. Like typically, there's metadata that you want to keep at the top level of a JSON, which kind of obligates you to use an object as the top level, right? So, let's say that we have a family, last name is Moore. There we go. So, key value pair. For the rest of this demonstration, I'm going to leave out the quotes because they're just a pain in the ass. So, we can also add a new property to the family, members. So the thing that makes a JSON is that any value can be any of the following things. Values can be ints, floats, bools, strings, all of the stuff that you expect, plus lists and objects. The thing that makes a JSON is this recursive structure. You can have the thing nested to many, many, many levels. A theoretically infinite level of levels. Of course, true infinities can't exist inside of computers, but let's just say the hierarchy can get so deep that you can't really see the bottom of it. Right? So, I can pull a list as, like, I have a list of members of the family, right? Now, within that list, I can create new objects which represent properties of the members of the family. So, for example, name, Nick, occupation, know-it-all. There you go. Name, Alexandra. Occupation, wife. Name, Felix. Occupation, child. Name, Cordelia. Occupation, asking, for mom because she's 2. Name Theo Door. Give you your full name, Theo. Occupation baby. And there you have it. An object containing a list of objects. But you can see how this is a useful way to organize data, right? We might add another field here, perhaps cats 2, right? Dogs 0, hamsters imaginary. This is actually a big problem in our house at the moment, that we have a lot of imaginary hamsters running all over the place. That is actually a serious thing that I just said. We do have a problem with imaginary hamsters. Like my son, who is turning 4 at the end of this month, we'll be like walking down the stairs and he'll be like, "Do you hear that?" And he'll look up and he'll say, "A hamster!" And it's, an imaginary hamster, but still a hamster to him, But it's just like they're everywhere, the imaginary hamsters. It doesn't matter where I go, he's always finding them. And it's always like the same 3 hamsters as well. They get around, But anyway, so that is a JSON. That's actually a relatively small one. These things can grow to hundreds, thousands, tens of thousands of lines, depending on how much data you're storing. You can imagine that inside of a Mongo database, these things can grow to absolutely monstrous proportions, right? So how do you get data out of them? Generally, by chaining access procedures, right? So we have access procedures for objects. We use the name of the field. We have access procedures for lists. We use an index. We combine a chain of those to be able to walk our way through the data structure, right? So, for example, let's say that I wanted to pull this information out of the database, or out of the JSON. Database JSON, right? Well, first, I have to go through members, right? Next, I have to go through item 0, 1, 2, 3. And then, to get there, to name, I have to use name, right? So, in JavaScript, the way that you would access it is family dot members dot, actually technically dot should be on this side. There you go. Members at 3 dot name. And that would retrieve that piece of data from the JSON. Does that make sense? So really, like, in the same way that in JavaScript you should get comfortable with the idea of method chaining, to work with JavaScript object notation, you should get comfortable with the idea of chaining accesses. Does this make sense? Everybody cool with this? Yeah, cool. I want to show you something a little bit kooky now. JavaScript also supports doing things this way. This also works in JavaScript. If you're a big fan of square braces, then you can do it this way if you want. So it's a little interesting because, like, technically this is more flexible because you can, like, literally, like, these are expressions, right? They don't have to be string literals. These could be variables. These could be compound expressions. You could, like, you know, you could append information to them. You can create attributes in objects on the fly with dynamically determined names doing things this way, right? Now, most of the time you won't, because the standard mechanisms are, like, good enough for most purposes, right? Occasionally you might be able to pull off something fancy with something like this, but I don't know. It's interesting to me that it does that. So there you go. You can also do things that way. Does this make sense? Are there any questions? Okay. How has the lesson been today so far? Has this been informative? Yeah, learning things you didn't know before? That's always the goal, right? So, I would now like to show you how you can deal with incoming JSON data on an AJAX request relatively easily. So, first, let's make a file, because we're not yet dynamically generating JSON. We probably won't until next semester in server side. However, we can still do files, right? So let's make a new file, call it fruit.json. There we go. At the top level, this will be an object. Somebody give me a fruit. Pineapple. Very good. Someone give me another fruit.
Dragon fruit.
Dragon fruit. Somebody give me a third fruit.
Tomato.
Tomato. Ooh, controversial. You want an even more controversial one, though?
Cucumber?
Cucumber. Cucumbers are technically fruit.
Really?
Yep.
Watermelons.
Yep. Anything that contains seeds is a fruit. That is the definition of a fruit. Fruits do not need to be sweet. Someone give me another fruit. Kiwi. Very good. That's a bit astringent, but we'll take it. Next.
Mango.
Mango. There we go. Very good. I think that's probably enough. So, I just would like to point out right now, right here, I'm using a slightly irregular form of comma, Pardon me, one of you gentlemen sitting at the back of the room, would you mind putting the lights in mode 3?
Is that a light?
Yeah, that's the light switch is just on the other side of the buttress. Yep, perfect. Thank you, exceptionally. So, this is a thing which I am in the habit of doing, but you will see rarely outside of me. This is a trick that I picked up from Haskell programming. It's the manner in which I'm managing my commas. So, you'll notice that I'm putting my commas on the next line rather than at the end of the line, right? There's this traditional thing, this traditional problem when you're writing structures like this. It's like you always forget a comma somewhere in here, or you put one at the end where one doesn't belong or something like that. And in some languages, they actually make it syntactically valid to put a comma here, even though there's no next item. But this isn't a universally applied rule, right? Sometimes you get in trouble for that, sometimes you don't. Depends on the language. Rust, for example, allows you to put a comma there. So, a comma management style which I personally like is to put the comma on the next line. When you do this, you make a dotted line that denotes where your data structure is, right? So, if you start nesting them, like maybe Kiwi isn't 25, maybe Kiwi is 40, comma 30, comma 20, just like that. You can see how, it's just from visual inspection, it's easier to read that way, Plus, if you put your commas on the next line and you do your braces like this, you will never forget one. You will never run into that syntax error, I guarantee it, because the absence of the comma is missed, because you start your line with one. But anyway, so this is my gift to you. I have had other professors at this college call me stupid for doing this, but I like it, and this is my gift to you, this special syntax. It doesn't work in all languages, but it works wherever white space doesn't matter. So, there you go. I don't think it looks stupid, I think it looks cool. So.
Which professor doesn't like it, just so we know, if we're in their class?
Oh, it was actually Raphael and the game design program didn't like it. I did this in Game Dev Club once. Yeah. But yeah, well, he's kind of an interesting guy because although that program is largely fluff, it's probably 80% fluff. And by fluff I mean non-technical courses, because it's design. They do almost no programming, and there's absolutely no confidence whatsoever that anybody in that program can do any programming at all. But they do 1 or 2 programming courses, and Raphael himself is quite a competent programmer himself. So nevertheless, he thought it looked dumb. But, so, yeah, I was perhaps exaggerating when I said professors, a single professor, thought it looked dumb. But he's also the only person who has ever seen me do it in front of people, so, I have a sample size of 1, and that one guy thought it looked stupid. So, anyway, so fruit.json. When you're storing JSON data in a file, you give it the .json file extension. If it's just plain JSON data, there are actually quite a large number of file extensions that basically, if you look inside the file, it's oh, that's a JSON actually. For example, save files for video games. When you have a video game, a lot of the time, the data that's is saved to a custom file format, the save files for Civilization games are .civ, if you actually take a look inside of those, a lot of the time you'll just see JSON staring back up at you. So, you know, once again, file extensions don't really exist. They exist, they just have no substance. I should be more refined in my criticism. File extensions exist, but they do not have substance. Alright? Alright, so files themselves have substance. Okay, so we have fruit.json. Let's open, oh, by the way, quick bash tip. If you want to return to a previously entered command, use the arrow keys, up and down. You can scroll through your history. You can even modify the items in your history. It's very fast, very cool. If you type history itself, you get all of your commands and when you entered them. So there you go. All right. So now let's write a fetch quest. Haha, instead of fetch request. I already made that joke today. Let's do a fetch request for that JSON file that we just wrote. Fetch fruit.json, then data.text, then function JSON and let's just log this to console. Why be fancy? There we go. All right. Now let's try her out. So, there you go. We have our data, but if you'll notice, it's using my my really cool comment style, or my really cool comma style, which of course it wouldn't be doing. Also, it shouldn't be doing. Also, there's no like drop-down arrows or like the hierarchy arrows to be able to collapse these things, which typically it does if you're looking at an actual data structure. This is just a string. This is just a string. We have yet to parse it. So, we can throw in json.parse JSON. And you can see the difference immediately. This is now a data structure. Cool? Now, we could do this, but we could also actually wrap this operation in at the previous level. We can just, here, where previously we were reading this as text data, but we also have a JSON method, which we can apply to the data, that extracts JSON rather than text. Now, it's still getting the text. All it's doing is calling JSON parse before it gives it back to us. That's the only difference, right? But it does save you a step. You can see the results are the same. Any questions? Okay, cool. No questions at all. Everything is crystal clear. Yes?
Can you show the code again?
I can show the code again, yes. There you go.
Thank you.
So, now, let's talk. Let's work on getting this gradually by stages worked up into something resembling an API call. we are still only doing file access, right? So, if you recall, API calls should be thought of roughly the same way we think of function calls. When we call a function, what do we need to provide, typically? Not in all cases, but typically. We need the name of the function for sure.
And any argument?
Any arguments we are providing. You can see here, we can think of the name of the file as being like the name of the function. As a matter of fact, in PHP, there is a design pattern called file level modularity, which basically means that in PHP, and I know I'm talking about PHP again, in PHP, files are functions. You should think of a PHP file as being a PHP function, right? So, we need to be able to provide data to the PHP function. Okay? So, where that data comes from on the web page, that is something we talked about previously, right? We can get data out of the DOM. Hopefully, everybody sitting in this room is quite comfortable getting data out of the DOM by now, right? What we need to do is we need to learn how to attach data to one of those. So, we already have a mechanism for doing this. We've talked about it a little bit previously, but it's good to go over it again. Does anybody remember the difference between GET and POST requests? We talked about this at the beginning of the semester. Let's see how well you guys remember it. GET versus POST. What's the difference? Yeah.
Although I'm not remembering completely, I remember it was like the position of the package, like what information is in one part of the package and what other information is not in one part of the package.
That's right.
I remember that certain parts of the package were encrypted and other parts were unencrypted.
Yes. So, GET and POST store the parameters we're sending in the packet differently. One is encrypted, the other is unencrypted. Do you remember which one is encrypted and which one is unencrypted? Yes?
POST is encrypted and GET is not.
Correct. The GET information is sent unencrypted. POST information is sent encrypted. So, if I were sending username and password, which would I use? Everyone at the same time? 1, 2, 3. POST, that's right. So, GET requests use URL parameters, right? So the information we are sending is encoded in the URL itself, right? So, let's take a look. I'll try not to have the video copy striked this time. Copy struck? Everybody knows it's my favorite example. There we go. Now that's an ad. Oh, okay. No, even better. Yep. I'm gonna, maybe if I keep it there, it won't get copy struck. I don't know, do they copy strike political campaign ads? That seems like a terrible idea. No, thank you. Oh, there he is. Okay. Mr. Astley is back. Okay. So, if I go to this somewhat hilarious picture of it, and I copy video URL at this time, well, let's see here. I'm going to actually, I'm going to edit there. I'm going to splice these up a little because it'll still work. and it makes my point better. Right. Oh. Stop. Oh, I lost it. Stop. So, yeah. So I don't know if you knew this about YouTube videos, but if you provided a t parameter, that is the offset in seconds that you want the video to begin at. You can generate these from the video itself by having the playhead at a particular point and right-click, copy URL at current time. Very useful if you want to send someone a short clip. So, let's take a look at the URL and break it down. So, this URL contains a lot of information, but it's broken down into regions. The first region is the packet type. This is HTTPS communication. So far, so good. Next is the domain. The domain will be youtube.com. Next is the root, or route, however you want to. I can never consistently pronounce it, so it's both root and route. Actually, you should say route, because that would distinguish it from like root directory, you know? Anyway, the next thing is the route. That's the route. Everything after the domain, but not so far as that question mark. When a question mark appears inside of a URL, that indicates the beginning of query parameters. Right? So, this part of the string encodes parameters. Parameters which we are sending to the server. So, for example, okay. Parameters occur in key value pairs, similarly to JSON objects. They are separated by the ampersand character. So, we can write it like that, right? And to make it maybe a little bit more explicit, putting the spaces in that you don't have time or energy for in a URL, that is how the information is broken down. So, attached to our link to the best YouTube video and music video of all time, we are sending to the server V having this code and T having this number. This is, of course, as everybody knows, the video code for the Rickroll on YouTube, and this is the number of seconds to offset it by. We are sending parameters to the server. And you can imagine that if we asked to watch something on YouTube and we didn't say what video, you know, it wouldn't load a video for us. It would probably kick us back to the dashboard page. In fact, we can test that. What happens if you ask to watch nothing? Yeah, it just redirects you back to the home page. So, does that make sense? We can send these to. All we need to do is to construct the string that contains the query parameters. All we need to do is reverse engineer this thing send our own data. Make sense? So far so good? Okay. So now, I'm going to modify hello.text. So this here is a root, but it's relative to the root we're already on, right? You should think of yourself as having a current working directory on the server already. That's handled internally, right? We can put the question mark character in, thus we now begin query parameters. We can then provide key value pairs, no spaces. The key and the value are separated by an equal sign. No spaces. No spaces. If there are spaces, the spaces become part of the thing. No spaces in a URL. No spaces in a URL. Okay? Name is equal to Nick. There we go. So now, when we send our initial query, there we go. Take a look at our network tab. You can see that the query parameter even appears in the on the surface of the packet. You can see that now we have a new tab, payload. Payload tells you what parameters you sent to the server. Name is Nick. You can do this from the URL address bar. You don't need to do this in Ajax. You can also do this from the URL address bar. You can encode these things into links on your page. Like you can write a link. You can have href include query parameters. That's a thing. All right? But we can send the server as much data as we like. If the server is not configured to pick up any of the data, it's not going to do anything. So, in the last 5 minutes of class, I will show you, very quickly, PHP Hello World. I'm going to rename this, though, to hello.php. So, in order for a file on the server to be processed as a PHP file, it must have the PHP file extension. So, I guess that is one case where the file extension does have substance. So, now, hello.php. PHP file, to execute PHP code, the PHP code must go inside of opening and closing PHP tags. There are reasons for this that I'm not going to talk about now. Okay, so in Python, how do you print to the console? In Java, how do you print to the console? In JavaScript, how do you print to the console? Anybody want to guess how PHP prints to the console?
Is it echo?
It is echo. Very good. Why is it echo? Because that's a bash command that does the same thing. Echo, hello, gents. PHP thinks it's an unholy combination of bash scripting, C, and JavaScript. It's like it combines some of the worst qualities of all of these things. So, echo. Also, in PHP, all variables have to start with a $sign. No exceptions. Echo, hello, comma. Oh, in PHP, guess what your concatenate operator is? It ain't plus. It's dot.
Oh.
So you may be asking yourself, what dot? That's not what dot means. Dot means method using a method or an attribute. How do you use a method or an attribute in PHP? This is how you do it, folks. Arrow. You know why arrow? Because that's how C structures are addressed. Structures in C use arrow, so that's what you get in PHP. So anyway, so now, the way that you read information from an incoming get parameter in PHP is this. You must access the get superglobal. These are called superglobals because they're not just global, they're superglobal. Name. Name is the key that gets you the value. Right? I save this. I head back here. Hello, Nick. Ta-da! So, as I said previously, it's kind of a little bit impossible to do a good demonstration of client-server communication without also showing you some server-side code. It's not going to be on the exam. You will have plenty of time to test you on PHP in the PHP course. The exam's going to be on JavaScript. Okay? Principles of client-server communication certainly will be on the exam. All of the client-side code is, that's testable for the exam. But I can't really do good in-class examples without doing some PHP, so I'm just going to do it. Okay? Consider this your soft introduction to PHP next semester. Okay? If you have any questions about the PHP code, though, I'm absolutely happy to answer them. Yeah. So that's all I have for you today. Thank you very much. Have a good weekend.
Take care.
Take her easy.
I'm sorry.